Alright, let's move to part 1b, tables and keys. Alright. Okay, so what exactly is a table? It's just a 2D representation of data that's stored in rows and columns. Right, so this table does not look new to us. We are so used to seeing tables like this, but there's just some names that need to be careful, some new terms. So for example, here tables are made of records and fields. What exactly is a record? Record is a single complete set of data about a single item. So for example, you look at this one, this row here is a record. Okay, so contains all the items, the complete set of data about this particular student. So his name is Adrian, and then his gender is male, and then his phone number is as such, right? A field or attribute refers to one piece of data about a single item. So in this case here, right, if I say that the field, the name of Adrian, name of this second row entry, right, is Adrian, right? So basically in this case, in this data here, I have 4 different fields or 4 different attributes: your reg number, name, gender, and mobile number. Okay. Then how to describe a table? So we put the name of the table and the various all the attributes inside. So this table here, right? This table's name is called student, and then the name of the attributes are reg number, name, gender, and mobile number, and represented as such at the bottom here, right? Okay, so look at relation. So in a relational database model, we should talk more about it later, right? Data are stored relations and represented in the form of tuples. Alright, then it's basically a collection of relational database tables. Okay, what exactly is a when's a table relation? So you must fulfill the following things. Okay, values are atomic, columns are the same kind, rows are unique, order of columns is insignificant, each column must have a unique name. So let's just look at this and see what we can do to explain it. Let's go to the next slide, that will help us. Right, so let's look at this table here, for example. Alright, so values are atomic. That means every record, every attribute, every record only contains one item. So I should not expect this mobile number, right, to contain the second mobile number, for example. Okay, if I have to contain a second number, I need to do something about it. I cannot say, for example, 92313291 comma, then write another number there back. This should not be this way. Columns are the same kind, right? Same kind here basically means in this each column here, right? Let's say for example this column for your mobile number, you're only showing your mobile number and nothing else. You cannot have somewhere in the middle, let's say AJ here, you have his email address. Alright. Rows are unique. Okay, so uniqueness, right, means basically every row should be identified from each other. Okay, how you identify it is besides the point here. Right, so you cannot have, let's say for example, you cannot duplicate the same person twice. So you cannot have another row containing Adrian's name, Adrian, gender, and phone number again. Right, the order of columns is not important, so I can put the name in front, then followed by the registration number, etc. That's not important. Then each column must have a unique name. This allows us for us to identify which column we are talking about. Alright, so now we can talk about this slide here. This is basically a table that we're going to work with. Alright, so we're going to talk about candidate keys. What exactly is candidate keys? Alright, so a candidate key is defined as a minimal set of fields which can uniquely identify each record in a table. Alright, so it basically tells a particular record apart from another record. So these are fields that when you look at that entry, right, you will know that, oh, this belongs to one person, this belongs to another person. Okay, you can tell them apart. Okay, so a candidate field as a result, right, it cannot be empty. It cannot be null. Okay, null basically means it's empty lah. Alright, there can be more than one candidate key for a table. Alright, a candidate key can also be a combination of more than one field. Okay, so you look at this table here, right, we try to see which one will be able to, which attribute will be useful, can be used as candidate key. That means you can tell each candidate apart from one another. Okay, the gender is not a good one because there's only 2 genders, male and female. The phone number is also not a good one because the phone numbers, right, might change over time. Some people might not have a phone number. So in this case here, right, the registration number is a good candidate key because usually it's issued at the start of the year when the student joins the school. The name to a large extent is quite unique here lah. Okay, because in this table here, right, all the names are unique. So if you look at, let's say you pick out, if you say your key is the name, right, you can identify each of them individually. But this will not work if let's say there's a repeated name inside your table. Okay, so in this case, my candidate keys are my register number and my name. All right, so this candidate key. Moving on, let's look at the next thing, primary keys, right? So from just now the candidate keys, right? We try to find a key that's most appropriate to become the main key for a table, right? So for this one here, right, it should identify each record in the table and should not change over time. All right, so name might change. Okay, you might change your name, but you probably can't change your gender and your phone number at the same time. So in this case, right, the name is not so good primary key. In this case, right, the best primary key here is your register number. Alright, so the register number is unique to everyone and won't change over time. Okay, no way of changing. Alright. Okay, of course we are thinking of a perfect world. No one changes name and gender. Alright. Okay. Alright. So then we can look at what are secondary keys, right? Secondary keys are very straightforward. Okay, so basically, right, any of your candidate keys, right, they are not selected as a primary key will be your secondary key. So for example, in this case, in the same example, right, we had the candidate key to be register number and name, but we wanted a primary key to be the register number. So the secondary key will be the name field. Alright, so this one is not so important, but good to know. Alright. Okay, then sometimes we need to make use of more than one key. Let's see what we mean over here. Okay, we talk about composite keys. Okay, so a composite key is a combination of two or more fields in a table that can be used to uniquely identify each column in the table. Alright, so uniqueness is only guaranteed when the fields are combined. When taken individually, the fields will not guarantee uniqueness. Okay, so for example here, right, let's look at this one here. Consider this student table. So a single field is not able to uniquely identify record, right? So, but you say, but it was the same table from just now, right? But look carefully right now, the register numbers are repeating itself because there are two classes. Okay, there's 18S12 and 18A10, right? So it's not possible to identify a student just by the register number, because you call for register number 1, there's two of them. There's Adam and there's also Adam from another class as well. Okay, so there are two Adams, right? So this is not a good primary key anymore. Okay, you cannot just use the registration number. But we can see that if we analyze our data carefully, right? Again, we should not use we might think, okay, we can form a composite key using the register number and name. But just now I show you that, okay, for number 1 Adam, right? Number 1 Adam is also in their class, and it's also a male, so it's not so effective anymore. Alright, that means we need to think of other option, which means here, because we are dealing with two classes, right, it makes sense to take the register number and the civics class together as the composite key. So these two keys together are now acting as a primary key. Alright, okay, then next we have foreign key. Okay, what exactly is a foreign key? Okay, so let's read this description first. A foreign key is an attribute in one table that refers to the primary key in another table. Right? It sounds a bit confusing, but we're going to use an example to show you what we mean, right? Okay, so let's say we have this class info table here. Alright, it stores the information about each civics class. So in this one here, you have civics class, and then you have civics tutor, and then the homeroom. So obviously, I think it's quite clear to see that for this table, right, the primary key should be civics class. Okay, so yeah, so because classes don't change, civics tutor may change, or the homeroom may change. So the class is the most stable one, most unlikely to change, right? Okay, then let's look at the other table, our original table here. Okay, so notice that this. Okay, let's show the tables first. Right, so you see this here. Remember, we have already identified our civics class as the primary key in your civics class table. Okay, then if you go to this class info table, right, the civics class is your primary key. But see that this civics class is also represented here in your student table. Alright, so this is the same. Alright, so what this means is that right now, inside the class info table, civics class is the primary key. Okay, but civics class also exists, the attribute also exists within the student table. So in this case, right, alright, it makes the civics class inside the student table a foreign key. Alright. So basically, one more time, your civics class exists as a primary key of your class info table, but civics class attribute also exists in your student table. Okay, so that means within the student table, the civics class is a foreign key. It's pointing to the primary key of another table. Alright. Okay, next. One last slide for this section. Okay, why do we need to do all these things, right? Okay, so why do we want to use a database? The reason for using a database management system is because there's a very good validation support. Okay, what it means by this is that you can basically set your software to only to accept certain types of data. Okay, to perform validation checks. Okay, right. So, yep. So for example, in your you create your table, right? Then you specify what exactly you are supposed to enter within a particular field. All right. So this will check. Okay. So each time you make, okay. So here, right, basically what this is telling you is that when you set up when you design your table, you set it up. Okay. Then each time you make a reference to it, right, you will do a check for you. Okay. So for example, say if you want to find information for a class, right? If you type in, let's say, the wrong structure of the class, right, you will not get it will prompt you. Okay, so for example, certain validation checks include this. For example, your registration number should be an integer. It's checking for whether it's integer or not. It should be unique numbers. That means you cannot have numbers that duplicate each other. Okay, name, this one is basically telling you this is a string type. Alright, so it cannot be empty as well. Okay, gender, it should be a single character. It's either F or M. Unfortunately, we're not so forward yet, so we just take F or M for now. Alright, then civics class we expect to be in this format, YYC, XX, etc. etc. Alright. Okay, so right now we should have enough information to go and do C4 intro to database questions 3 and question 9. Right, once you're done, you can move on to the next segment.